Am I audible? Good afternoon, everyone. Am I audible?
Yes, ma'am.
Okay. And somebody was asking in the group about the IS code, I guess.
Yes, ma'am. It was me.
Yeah, and the notes also, na. So I will provide you whatever I have taught till now. I'll give you the notes. Okay. I'll give you the
Okay,
notes
ma'am.
and also the soft copy of the IS code. You should have your hard copy also. Okay. When I send you the soft copy, keep the hard copy with you. IS 800 2007 for your steel designs. Okay. IS 800 2007. And what I was about to say. Yeah. Notes I'll be providing. Steel code you need. The steel code, yes, you have to have your steel code. So that also I'll provide you. You people are coming for physical classes, right? After 20. So bring your
Yes, ma'am.
IS code with you for the classes, physical classes. Then we have our morning class. I have given you the assignment. That assignment also, when you come on 28th, submit that assignment, write in small copy, because further also you may get assignment. So write there the
Ma'am,
assignment was what? Assignment was your what are the different types of groove wells, and the draw and show, no? You had to show the groove wells, different types of groove wells with the diagrams. Okay. Also, you will add, let me write here in the chat box. What
ma'am,
are the,
about the cement, will write in A4 paper or notebook?
if you want to give in notebook, you can give. If you want to give in A4 size, you can give, because later also, after this also, you may get some assignments. So that if you write in copy, I think it is better, because you will have your assignment together with you. Nah.
Okay.
Yeah. So, okay, wait, I'm giving you the assignment question once again in the chat box. Assignment one. Okay. Question one is what? Um, there are three different types of groove wells. Question number one. In the first class, I had given only one question. Now I'll give you some more questions. Okay. Question two is your wells. Okay, this is sufficient. Question number one and question number two. What are the different types of groove wells? GROVE. Okay, I missed it. Groove wells. Explain with figures. You have to draw all the types. Okay. And the second question is, what are fillet wells? We have discussed that in the class. What are fillet wells? Okay. The slot wells. Once you come physically, I'll explain you the slot wells, and then we can take some question on that slot wells, because till now we are doing with the fillet wells, right? So these two you can submit as your first assignment when you come once and join the college. Okay. So let us, we where we left, we'll start now from there in the morning. Um, my screen is visible.
Yes, ma'am.
Okay. So in the last class, in the morning class, we had done this question where we had two plates. This one was 80, sorry, this one was 120 into 8 mm. This one was 80 into 8 mm. So draw yourself the diagrams. This is the figure. So you draw the figure, like how much should be the 8 mm, measure and draw, or simply also you can show a problem. So you can imagine, I guess, that this is 120, this is 8 mm, this is also 8 mm, but this is 80. So we had to design in such a way that these two plates, when joined together by fillet wells. How you know that this is your fillet well? You are going to join these two plates with the help of fillet wells. How you know? We know this by this one. Here you see in the question, it is mentioned that lap joint. This one, this plate, this is one plate, this is one plate. These are connected in a lap joint. Lap joint means what? Lap joint means when it is when two metal plates or two metals are overlapping each other. That means they are lapping over each other, right? So when it is a lap joint, that means they are overlapping joint. So you know that when we use fillet wells when we have a lap joint. In lap joints or overlapping joints, we use this fillet wells. So our weldings will be here, here, here. These portions, all these portions will be welded. So all these are welded. Okay. So these is this smoothly. It is going to go like this. Okay, whatever. So the size is given to you 6 mm. We are asked to design now the connection. Design the connection in the case of welding means we have to find out, since the length of the weld is not given here, so obviously we have to find out these length, how much is this length of the weld, so that once we know the strength per mm of the length, that for this connection, this this size 6 mm size of weld is used. And size, I think I told you in the first fillet 12 class last time that when what is the size of the well? What do you mean by size of the well? Anyone? What do you mean by the size of the well? In the very previous class, like last week, I think I had explained you. What was your size? What do you mean by size of the well? Anyone? If you remember? Hmm? No one? You're not listening to me. Like last week, I think I had said you this thing. No one? Okay, fine. So size was what? Size was your the length of the leg. This was your fillet wells. They look like this. Okay. So these are the size of the. These are known as your size of the well. This the leg of the weld is your size of the weld, nothing but the size of the weld. And what do you mean by the length of the weld? Length is this one. This entire portion which is used to connect these two plates is nothing but the length of the weld. So we had discussed these things like how you have to design, you know the size, you know the throat thickness, you know 0.7s. So after that, you know the design stresses, how much Fu by root 3 gamma mw, you know. Then you know gamma mw you got from your IS code table 5. We have discussed in your IS code. We have showed you. We discussed that IS 800 2007 page number 30. Table 5, we have this partial safety factor. We get there were two partial safety factors for your gamma mw. That means if it is shop fabrication, then 1.2 it was, I guess. Then again for field fabrication, your gamma mw is 1.5. Then we discussed that this was our design stress. We found that our design stress was this much. Then we came to the design strength. per mm length of the well. Why per mm length? Because we don't know now the length of the well. It is not mentioned in our question. We are asked to design. That means just we know that these two plates are to be joined together. They have to carry this 125 kilonewton of load. The connection should be such. The overlapping connection should be such that it can carry 125 kilonewton of load, right? So what happens, that's why we are finding out the per mm length, the design strength per mm length of the weld. So once we know the entire length of the weld, we can find out the complete design strength for the entire connection. Okay, so here we don't have, so we have considered per mm length of the weld, how much is the strength we are checking. So FWD, you know this value, we already got. Design stress, length is per mm, so 1 into 1. Then throat thickness we have got how much? This is our throat thickness, which is 4.2 mm. This one, 4.2 mm. So we got our design strength per mm length to be 662.802 Newton per mm. Okay, so now we have got the design strength per mm length of the well. Now, what is the next step? Because since we are designing, we have to know that how much length of the weld you are providing, because that depends upon how you place the weld also, right? No, sorry, how you place your this plate, 18 to 8 mm plate. If you move towards right hand side, if you move to a right hand side, these portion of the weld and these portion of the weld will increase length. This will remain same, however, because whether you move this side, if you move this side your plate, this length is going to decrease and this length is going to decrease. So we will be designing now how much is the length of the well. So how to know that how much is the total length of the well? We know the per mm length strength of the well, strength of the per mm length, but to know the complete strength, we have to know what? We have to know the entire length. Once we know the length, that is our design. Okay, so now how we can find out the effective length of the weld? Effective length of the weld. Okay, effective length of the weld is given by what? Factored load by your FW. Sorry, this is PWD. That means the design strength. PWD. Okay. So factored load is how much? Our factored load is given to us to be 125 kilonewton. So 125 into 10 to the power 3 kilo comes. Then we have PWD, that is the design strength of the weld per mm length. PWD design strength. Okay. Then we have divided by this factored load your effective length. How you find your effective length? We find our effective length by dividing the factored load with the design strength per mm length. So we got our length, effective length, to be 188.59 mm. That means we can consider it, we can take it to be 189 mm, right? See this one, this 189 mm. Since you are designing the weld, it is up to you. Like for how, like I told you here, if you move, how you place your this plate, depending upon that will be your effective length of the weld. So if you move this side, this length is going to increase. This is going to be constant, but this is going to increase. So if this is increasing, this is also increasing. So ultimately your entire length of the weld is increasing. But if you move this side, your entire length of the weld is decreasing. But if it is decreasing, we have to check whether it is able to carry or resist this load or not, 125 kilonewton load or not. Okay, so what you have to do now, the effective length we have got it to be 188.59. So it is up to you how much you want to take. Here we have assumed it to be 189 mm. We consider it to be 189 mm. Okay, we can take it to be 190 also. Okay, so we have what? Now, since you know the effective length, that means the this entire length from here to here to here, all these entire length of the weld, you know, since you know this length, so you have to know this portion now. that how much is this length, how much is this length. So that you will get how length of each well will be how much. Now we are considering only this portion, okay, this one. So that will be total length of the well is how much? 189 mm. So 189 divided by 2, since there are two, this side one connection. So this is 189 divided by 2, that is given to be 94.5. So we have considered it to be 95 mm. Now that means your one of this side, upper top side is 80, sorry 95 I guess, yeah. 95, this is 95, this is 95. Okay. Now you see from cross number 10.5.5.2, page number 79. Correct? 79. So if we go to the page numbers, see here 79 clause number 10.5.5.2 of IS 800 2007. 10.5.5.2. This one. 10.5.5.2 you are looking here, this one. What does this clause say? This clause say that the clear spacing between the effective lengths of intermediate fillet wells shall not exceed 12 and 16 times of the thickness of the thinner plate joint for compression and tension joint respectively, and in no case be more than 200 mm. Now you see here this one. This is your fillet wells, these two, and here in middle one, this line, this well is there. I'm telling that this is not there, but if you want to provide here, okay, this entire one is your effective length of the well, but this one, and this one, these are your intermittent. This is your intermittent fillet well. That means the distance between these top one and this bottom one. Okay, suppose this one, this top one, this top one is okay. Suppose this top one and this bottom one, these two are welded, right? This welding is not so long, okay. Short weldings are there. So the distance, the spacing, clear spacing between these two shall be how much? That between the effective lengths of intermediate wells shall not exceed 12 times and 16 times of the thickness of the thinner plate. That means now we will check 12 times and 16 times, right? So you see here 12 times of the thickness of the thinner plate and the 16 times of the thickness of the thinner plate. We are going to check these two. Okay, because that distance should not be less than this one. Okay, so 12 times the thickness of the thinner plate. Thickness of the thinner plate is how much? These two were the plates 80 mm into 8 mm. This one was how much? 120 mm into 8 mm. So 8 mm is the thickness of the plate. So now 8 mm, both side it is 8 mm. So if suppose this would be 9, suppose this would be 9 mm. If this would have been 9 mm, then we would have taken the thickness. Now for 12T and 16T consideration, we would have taken these T. Okay, but since both are equal, 8 mm, this is 8 mm and this is also 8 mm. So we'll do what? 12 into 8, 16 into 8. Right. So you see here 96 mm. This here 12 times the thickness of the thinner plate is how much? 96 mm. This is 128 mm. So length of the designed weld is 95 mm, that is 96 mm. Okay, you see here, it should not exceed 12 and 16 times the thickness of the thinner plate joint for compression, and in no case 200 mm. So you see here now, you have checked both this 12 times the thickness of the thinner plate and the 16 times the thickness of the thinner plate. Now you see here, this is 96, this is 120. Which one is smaller? This is smaller. That means 96 mm is smaller. That means 12T is smaller. And it was told in your ISO that it should be it should not exceed either 12 or 16T, whichever is smaller. And if these 12T and 16T by chance, if this would have been like, suppose this is, for example, if you say this is 211, this is 202, suppose I'm telling you, if this is 202, this is 211, what will happen then? Hmm? So in the IS code, it was said that smaller of these 12T and 16T. So smaller one is which one? This one, 201, sorry, 202. So we would have taken these. But again, one more thing is written in your IS code, that is for compression and tension joint, and in no case more than 200 mm. That means if your 12T or 16T is greater than 200 mm, that means what? These, whichever is smaller, that was supposed to be the spacing, the clear spacing between that. But since these both are greater than 200 mm. For example, I was telling you, like this two, if both 12T and 16T is greater than 200, then we consider it to be 200. Our length of the design well to be 200 mm. But here, since this is not 200, this is not 200, this is less than 200. One is 96, one is 128. So we can take the length of the well to be 96. Okay, so 96 mm. So in no case it should be what? The clear spacing between the effective lengths of the intermediate fillet well shall not exceed between 12 and 16 t, unless otherwise specified. The intermediate, okay, this is for butt wells. Okay, this is for normal wells. Okay, unless otherwise specified, the intermediate fillet welding shall have an effective length of not less than 4 times the well size with a minimum of 40 mm. Okay, so you see here, now since you're this 12T, the lesser of these two is how much? Lesser of this is this one, this one, 96 mm, 96 mm. So now what we have to check is your this 90 smaller of these two, which is 96 mm, whether it is greater or smaller. You see here, clear spacing is, okay, 120. Length of the design weld is 95 mm. Here somewhere we had cleared. No? I think something is mistaken here. Check. Okay. Yeah. See here. This one we had calculated before, na? 95 mm, which is your length of the each weld. Okay. This means this one. Where it is? This one, length of each weld, we have calculated the length of each weld. That means this length is how much? 95 mm. So 95, 95. So we had checked that these 12T and 16T, if this is greater than your this one, length of each well, that means here this length, it should be less than your 12T or 16T. Okay, so you see here we got it to be 96, 120. Now what is our length of each weld is 95 mm, which is less than your this minimum one, that means 96 mm. So therefore our design is safe, we don't need to provide this length. This one is not required. If we use only these weld and these weld, it is sufficient to carry this much 125 kilonewton of load. Okay, so you have finally designed your this fillet weld. Okay, that means what we had checked the throat thickness, we had calculated the design stress, which is Fu by root 3 gamma mw. Then we had calculated the design strength per mm length of the fillet weld. Then we had calculated the effective length of the fillet weld. Effective length means the total length of the weld was 189 mm. That means the total. So first of all, we'll check like if we provide from this total, this entire should be welded, right? But the total length was 189 mm, right? So we will check first of all. We'll use here this blue color ones. We will use the valve at the top and at the bottom, and we will check whether it is safe or not. That means it can carry this 125 kilonewton load or not. If it is greater than that and we can carry 125 kilonewton of load, that means not necessary to provide here your welded connection. You don't need to provide the weld here. Okay, if you provide the weld here at the top and at the bottom, it is sufficient. So how we check that? We check that we have calculated the on each side, that is top one and the bottom one, how much is that size, 95 mm. We had taken it to be 95 mm. Then from clause 5.5.2, 10.5.5.2, we have checked the 12T and the 16 times the throat thickness. So the clears. Okay, so that should not be the lesser. Your that this length of the each fillet well, which is at the top and at the bottom, that should not be less than your this one. Any one of this lesser of these two. So it is less. Sorry, it is less. It should not be greater. So it is less. Therefore, our design is safe. We don't need to provide this one. Okay. You got. Let me check once. My screen is visible. My screen
No,
is
ma'am.
visible. Okay. Let me share again. Okay. Ways. Okay. Visible?
Yeah, yeah.
Okay. So in this particular question, what we have seen that we were not given the size of the well. Sorry, we were given the size of the well. We have not provided this. I think I should run this. How to run? Okay. So the ultimate design is what? Ultimate design is that you can provide only this top portion and the bottom portion, this connection. If you do not provide the transverse well, then also it is safe. Okay, why to provide extra welding and make it uneconomical, right? So if you don't provide also these transfers well, it is okay, well and safe. If because if you don't require that, but then also you are providing, so obviously you are this thing no? You are making it uneconomical, you are wasting your money, time, etc. So and making it heavier also, somewhat heavier also. So you have to have, we have designed this. Okay, now we'll check another question where you will have opposite to these questions. Like we'll check how it is different. How are the different questions which you're going to get? Like this is one question. simple, like how you have to follow the IS code for this. Now we'll take another question. This one. This was safe, well and good. Now we'll take another problem where we have to place 150 mm into 10 mm plate and 180 mm into 10 mm plate. 180 into 10, sorry, 180 mm, and we have a 150 into 10 mm plate, and this plate is 180 into 10 mm. Okay, the bigger one. So a similar connection is given to you, that means overlapped. Easy and simple, that is overlapped to you. Right. Now what you're going to do here, design it to be directed in a lap joint. This is also a lap joint, so you know that this is a fillet well connection. Now design the connection for full strength of tape. I think we'll take this problem on the next class. Meeting is going to end now. So for today we'll end here. Next class we are going to, next class, when is the next class? 14. Your ma'am is going to take tomorrow. So I think you will be physically present in the next class. So okay, we'll do. I think I'll have one class here on Tuesday, 21st. So we'll meet there physically then. Okay.
Okay.
Okay, I will share the link now. Let me share the link for design structure. Yeah, I have shared the link in the chat box. Go in the chat box and give your attendance there.
Ma'am,
Hmm.
do you upload every lecture on YouTube?
Hello? Can you be little louder?
Do you upload every lecture on YouTube?
Lecture on YouTube. Yeah, every lecture, and then your attendance is uploaded, right?
Okay.
Your attendance is also uploaded. I think you have to give your attendance there also. You have to check your attendance is given or not, and then you will get to give some ratings. I think so. After that, your attendance is verified and approved in the ERP portal. So manually, I am taking here, but for the reference purpose your attendance, but in the ERP also the portal will take your attendance. That means I upload and I give your attendance in the ERP na? So that ERP, when you check your attendance and give the rating or something like that, so then that approves, I guess, for you people, for students. Lecture you in YouTube, that means the every class which I'm taking, that is for every faculty, whatever the classes they're taking online, everything is uploaded in your this portal though. ERP, YouTube one is there, I think. Yeah, YouTube, in the YouTube we upload. I'll give you another link also later for different voltage connection, etc. There you will understand more properly. Okay, I'll give you attendance there now. I think everybody has given. You people are coming, na?
Yeah, yeah, ma'am.
From 20. Everybody is coming from your class. Yeah, final year students.
Yeah, I guess so.
Hmm. Okay. Good then. But I don't know whether the classes will be online or offline. I think offline maybe. It will be fixed then. Later. Offline classes will only be there. Okay, then I think you have given your attendance. We'll end the meeting here, or else it will end itself only. Thank you.